This is SAP 2000. This is the main taskbar, and these are some shortcuts. And here this is the 2D wave in XY, exit, and YZ planes. Here, first of all, uh, we have to go for new model. Uh, Here we can select default units of the design, and here I have selected kilonewton meter and Celsius, and default materials is Indian standard, and we have to select a template. I select grid only. uh, Here we can choose number of grid lines in y direction and any other direction. Okay, there are two grid waves. This one is for 2D wave, another one is for 3D wave. Here we can select XY wave, XZ, and YZ. Here normally we use this grid view for 3D view, but also we can use this as another 2D view. Like here we can see XY plane here, we can see XZ. This is the AutoCAD view of the design. Here, this is a ground floor plan. Uh, the walls of the building goes from this grid, from here, then here. So we have to select grid lines 4 from 1, 2, 3, and 4 in X direction, and again we have to select 1, 2, 3, and 4 grid lines in the X direction, sorry, Y direction. So let's enter it in the SAP 2000. Double click on the grid point, X direction. This is the center to center distance for 4170. Sorry, basic grid line is this one. We have to take 1120 as the first one. So now Y grid data. This second grid line is from 5050 millimeters. Here in Z direction, uh, the dimensions are selected from the floor to the surface of the upper floor. It is 2750. We don't need these two grid lines, so we can delete them. Delete. So now we have defined the grid lines. So let's okay. Now we have to select we have to define the material properties. So we go define materials, and here we can select materials. So if you want, we can add new materials. Region India, standard India. Here I select M2 integrate concrete. Yeah, everything is okay. So now we have to define rebars. Here I select rebar FA 500. Okay, and let's modify it. Now it's FE 500. Okay. Next we have to define material section properties. For that we go to section properties. Here we can select uh, define frame, tendon, cable, and area sections. First I am going to define a beam. Here we select concrete, then rectangle. We are rename this as beam, and the dimensions are selected for beam. This depth is 300 millimeter, and width is 230. The material selected is M20 for concrete reinforcement. Material is FE 500. We have to select beam. Concrete cover I selected is 30 mm in both sides. Sorry, 25 in both sides. Okay. Next, I'm going to define column. Dimension of the column 300 into 300. Material I have selected is 20. Now we define slab. Here I got to define section produced in 80 sections. Here I add new section slab. Uh, the, here the slab is 150 mm. Material selected is M20. Okay. Now all section properties are defined. So next we have to draw the building. Now we can model the building. I select draw frame, cable, and tendon. Here this is the XY beam. You can see in this flow there are no columns are running. So we go to the first row. We select beam. Likewise, we have to draw beams for second floor also. I have selected the XZ plane, so now we can draw columns. In this ground floor plan, there are one, two, three columns here. In the first grid, then one, two, three, four grids are in the second grid, and again three in the third grid, four in the fourth grid. Let's draw. Now I have completed drawing columns and beams. Now what's left is to draw the slab. I go for XY plane. Now here you can select one of these to draw slabs. Here I select, because all of these are rectangular slabs, I select this one, rectangle area, and select slab. Now we are in the first floor. So here in the first floor, one, two, three, four, and five slabs. First floor slab is completed. Now let's go to the second floor. The second floor, the floor is completely covered in slabs. So now I have finished the modeling, the building. We can use this set display options in 3D view. The building is completely fine. After modeling, we have to fix this structure to the ground. So like this, we have to select all the. First, we have to go to the ground floor. Then we have to select all. Then we have to go assign, joint, strengths. Then we have to select fixed. Okay. Now the building is fixed to the ground. After that, we have to define the loads. So therefore, go define load patterns. Here, dead load is already defined. Here, self weight multiplier is one. That means software is automatically calculating dead load. Uh, so we have to define the other loads which we have to apply manually. So X load is wall load. Uh, it's type dead multiply 0, which means we have to apply it manually. Live load. This type is also live. And now we have to apply loads. So let's go to the docker drawing. Here, walls are running over these beams. Uh, so so we select, this is first floor. So we select these floors. Sorry, these beams. Only in this beam, there's no wall running. So assign frame loads distributed. Here, here we can add the wall load. It's at here wall load problem, but load reduces gravity. Uh, now we have now we have the uniform load. Here we select unit weight brick as 19.2, then wall thickness as 0.23, and 2.75 is the height of brick wall. So input load equals 12.144 kilonewton per meter. Okay. By selecting display object load assign frame, we have to select wall. So now it shows the applied wall load in the structure. Now we have to apply the floor finish. So for that we have to select all the slabs in this structure. For that, if we go to select, there are properties, various sections. So here slab is here. So we select slab. Now all slabs are selected. Then go to assign area loads, uniform shell. Now we select floor finish, global which is at the uniform load here, and it's 1 kilonewton per meter square. Now we have to add the partition load. So we go to previous selection, except the roof slab. All the other slabs are applied with the partition load. So go to the floor, you select the slabs on the top floor. Then we go to assign uh, area loads, uniform shell. We select partition. Here the unit load of the partition wall is 1. which we use for half click wall. So apply. Okay. Now we have to apply the live load. So go to previous selection. Go to assign area loads uniform share. Here we select live and the load is 2 kilonewton per square 2 kilonewton per square meter, which is for residential building. So live. Okay. Uh, then we have to apply uh, roof live load. So we got the floor. Select all the slabs. Then we go again as assign area loads in function. We select roof live. And give the load input load is 1.5 kilonewton per square meter. Okay. Now all these slabs, beams and columns have to coordinate accordingly. So we have to fix them. So next we have to define the diaphragm. So first we select this slab, this whole floor. Then we go to sign joint constraints. Here define joint constraints. This is a diaphragm here. This is diaphragm one. Okay. There are two floors. So select it. We add another diaphragm two. So sun is diaphragm two. Okay. This one is diaphragm two. Apply. Then we go to the first floor. Then we can select everything on that floor. And then again click on type one. Then apply. Now we have to define mass source. For that we go to define mass source. Add new mass source. Here we select specified load patterns only. Hit at load one. Now we have to define load combinations. Therefore, we go to define load combinations. Here we click add default design combos. Select concrete frame design. Okay. Here there are 13 combinations. First one we ignore. From second one onwards there are 13. For each and every one we have to we are going to rename them because we have to apply these loads. So first of all we have to define rename them like this. Here scale factor is 1.5. So we rename this like this. And we rename all of this. Now we have completed defining load combinations. Okay. Now we have to analyze the structure. So we can press this button, run analysis. and now it will show the deformed shape. Here we can click start animation. There are various types of loads acting on this structure. So to know how the shear force diagram and moment diagram, we have to first we have to define the load combination. So we next go to define here load combinations, where we have to take a combination of all these loads. So we go to add new combo. Here we select envelope. Here we type envelope. We select envelope here. Then we have to add these loads one by one. And select this one. Combination add. Next we have to see the uh, shear diagrams and moment diagrams. So we go here. Start start design check of structure. Now to see how the shear diagram and moment diagram, we just go to here. This we have to click this show forces stresses, then frames cables tendons, then we have to select envelope. Here we select envelope. Okay, now we can see the shear force and moment diagrams. Like we just click here, right click, here it shows here it shows the maximum. Here it shows the maximum shear forces and minimum shear forces, maximum moment and minimum moment. Also we can scroll this and we can see moment and shear forces at that particular place. Next we have to see how much reinforcement we have to provide. So we can we, here we can go to design concrete frame structure and let's start design check of structure. Where you design Newton, millimeter and centigrade. Here it shows the amount of steel we should provide. Here it's 1129. That means in mm square. That means that's the amount of steel we have to provide. Now there are some checks to be performed to know whether this our structure is safe or not. So we go to start concrete design, check of structure, then we select verify all members passed. Here it says all concrete frames pass the stress capacity check. So it's just one check, and we have to perform some other checks also. Also here we can select display design info. So from this one we can select visual reinforcement, rebar percentage here. So like let's select rebar percentage. Okay. Now it shows the percentage of steel we have to provide to make this structure stable. Next we go to display design info again. Here we select PMM interaction ratios. Here P means axial load. A here it means moment in x direction and moment in y direction. Here it shows all the columns in orange color. That means it's okay. If it's red, that means the structure fails. Here all the columns are in orange, so that means the structure is safe. Next, we go again to display design info. Now we go beam column capacity ratios. Here, always the column must be stronger than the beam. So here in these ratios, always the beam column ratio must be lesser than 1. Here for all the values are lesser than 1, so the structure is safe in this check also. In this case, the ratio has to be greater than 1. So all the values are greater than 1, so the structure is safe.